Hi, welcome. Thank you for joining me today. Today we're going to talk about graphing absolute value functions. So lately we've been doing a lot of graphing, and today is going to be no exception. We're going to continue on with graphing. So first, just a reminder of what an absolute value is. Remember, the absolute value is just the distance a point is away from zero. So the absolute value of 2, because it's 2 units away from 0, is 2. And the absolute value of negative 2, because it's 2 units away from 0, is also 2. Okay? We'll just talk about some other terms here. First of all, the vertex. The vertex is the highest or lowest point on an absolute value graph. It could also be the highest point on a quadratic graph, but since we haven't talked about those, we'll get into that later. The minimum, of course, is just the lowest point on a graph, and the minimum will yield the smallest value in the range. And so the maximum, of course, is just the highest point on the graph, and the maximum will yield the largest value in the range. Okay, and first, parent function. So we're talking a little bit about parent functions now. Parent function is the simplest form of a particular type of function, and all other graphs are compared to the parent function. So there are a lot of different parent functions. Y equals x is one example of a parent function that we've already looked at. Today we're going to look at y equals absolute value of x. Some other parent functions might be y equals x squared, or possibly y equals x cubed, or y equals the sine of x. So there are lots of different parent functions out there. So today we're going to focus on the absolute value. Okay, so in our first example, graph y equals absolute value of x. So I thought it would be a good place to start is graphing the parent function. So two basic easy steps for graphing these. First, make a table of values, and then once we have a table of values, we'll plot the points and graph. Okay, so when we're making our table of values, it's always good to choose points, first of all, that might be near a particular value. So when we're making our table of values, we want to choose something that's always close to the vertex. And we should try to keep one of our points as the vertex in our table of values. So in this case, I'll show you here in a minute how to find where the vertex is, but in this case, the vertex is at 0, 0. And so notice I have my table of values centered around 0, 0. And so I chose -2, -1, 0, 1, and 2. And of course, when we put -2 in here, we get 2 out. So the y value is 2. When we put -1 in here, the y value is 1. 0, 0, of course. When we put 1 in, we get 1 out. And when we put 2 in, we also get 2 out. And so now and remember, this just represents a set of points. So I'm not going to show the points every time, but this represents the point 2, 2. This represents a point -1, 1, 0, 0, and so on. Okay, so this is just making a list of points that we're going to graph. And so from there, we plot the points. So 0, 0, -1, 1, -2, 2, 1, 1, and 2, 2. And once we have our points plotted, go ahead and connect them with a line. Remember the arrows at the end of your lines to show that it does continue off from there. So a couple other things just to point out. First of all, here is our vertex. And it is a minimum value in this case because it is the lowest point on the graph. So our domain of this particular function is all real numbers because we can put in any value for x. There is nothing stopping us from putting a particular value or a particular number in for x. And our range, well, since no matter what we put in, if we put in a negative number, it's going to become positive. Or if we put in a positive number, it stays positive. And so this minimum value, remember, represents the smallest value that we will get in our range, which is 0. So our range is y is greater than or equal to 0. Okay, next graph. Graph y equals the absolute value of x minus 3. Okay, so remember kind of order of operations here. We're going to take the absolute value of the number first, and then we will subtract 3 after that. Okay, so again, my vertex is going to be at 0. And so I chose, once again, numbers around 0 for our table of values. So once again, -2, -1, 0, 1, and 2. So when I put in -2, this becomes 2 minus 3, which is -1. So we have the point 2, -2, -1 is right here. Okay, -1, when I put in -1, it becomes +1, minus 3 becomes -2. So we have the point -1, -2. -1, -2 is right here. When we put in 0, absolute value of 0 is 0, minus 3 is 3, -3. So we get 0, -3. And again, that's the vertex, the minimum value. When we put in 1, 1 minus 3 is -2. And when we put in 2, 2 minus 3 is -1. So I've plotted all 5 of those points, and once again, connect them with a line. Remember, the domain is still the same. It hasn't changed. But this time, since the graph has moved down from where it was before, our range now becomes y is greater than or equal to -3, because it's moved down here to -3 now instead of at the origin. Okay, next graph. Graph y equals the absolute value of x plus 2. Okay, so notice this time the x plus 2, the whole thing is inside the absolute value symbols. So here's a good way to tell where the vertex is going to be. If we take what's inside these absolute values here and set it equal to 0. So we can write the equation x plus 2 equals 0 and solve that for x. So that's easy to do, just subtract 2 and we get y equals -2. So I'm going to center my table of values around -2. So I'm going to pick a few points to the left of -2 on the number line, a few points to the right of -2 on the number line. So I have -4, -3, -2, -1, and 0. And now we're just going to put each of these numbers in here and evaluate it. So -4 plus 2 is -2. Take the absolute value, we get +2 out. So we have the point -4, 2. -3. -3 plus 2 is -1. Absolute value is +1. So we have the point -3, 1. When we put in -2, well, remember that's our vertex. That's what we found over here. So -2 plus 2 is 0. Absolute value is still 0. So we plot the point -2, 0. Moving on, -1. -1 plus 2 is 1. Absolute value is still 1. So we have the point -1, 1. And if we put in 0, 0 plus 2 is 2. Absolute value is still 2. So we get the point 0, +2. So once I plotted all those points, connect them with a line, I do have my arrows on the end showing that it continues on. And so we're done. And just a quick reminder on the domain and range, all real numbers for the domain, and y is greater than or equal to 0 for the range. And I did label my vertex. Again, it is a minimum value for our vertex this time. Okay, example 4, moving on. Graph y equals the absolute value of 2x minus 4 minus 3. Now, it might be tempting to maybe combine these somehow or something like that. But remember, it's kind of an order of operations thing. We have to do what's here first before we can subtract 3. So we need to find, once again, what value of x will make this equal to 0. So over here I've set up my equation. 2x minus 4 equals 0. So I add 4, we get 2x equals 4. Divide both sides by 2, we get x equals 2. So I'm going to center my table of values around +2 this time. So some numbers smaller than 2 would be 0 and 1. Some numbers bigger than 2 would be 3 and 4. So I have my x values. Now let's just plug each one in and see what we get. So when I put in 0, 2 times 0 is 0, minus 4 is -4. We take the absolute value and get +4 minus 3 gives us +1. Okay, when we put in 1 for x, 2 times 1 is 2, minus 4 is -2, But take the absolute value is positive 2 minus 3 is negative 1. Okay, when we put in 2, well, we kind of already talked about that here. That's going to make this 0. 2 times 2 is 4, minus 4 is 0, minus 3 is negative 3. Okay, moving on, when we put in 3, 2 times 3 is 6, 6 minus 4 is 2, absolute value still makes it 2, minus 3 gives us negative 1. And last one, 4, 2 times 4 is 8, 8 minus 4 is 4, absolute value is still 4, minus 3, 4 minus 3 is 1. So I have all of my points here. So I have the point 0, 1, 1, negative 1, 2, negative 3, 3, 1, negative 1, and 4, positive 1. I've plotted all my points, connect them with a line. Okay, so here's my vertex again at positive 2, and our domain is all real numbers still, but our range is y is greater than or equal to negative 3 because it's moved down to negative 3 this time. Okay, hopefully you've got all that so far. We'll take a look at one last graph here. Okay, graph y equals the opposite of the absolute value of x minus 3 plus 1. Okay, so once again, this time you can kind of just look at this. Think about what makes this 0. Well, if we put in 3, 3 minus 3 is 0. So we're going to center our table of values around 3 because that's where the vertex is going to be. So I have 1, 2, 3, 4, and 5 for my table of values. So let's put in 1. 1 minus 3 is negative 2. Absolute value makes it positive 2, but now this negative sign out front makes it negative 2 again. So negative 2 plus 1 is negative 1. So we have the point 1, 1, negative 1 right here. Okay, so let's put in positive 2. 2 minus 3 is negative 1. Absolute value makes it positive, but this again makes it negative. So negative 1 plus 1 is 0. So we have the point 2, 0. When we put in positive 3, 3 minus 3 is 0. Well, remember, that's where our vertex is. So, and the opposite of 0 is still 0. Plus 1 is up here at 1. So we have the point 3, 1. 4. 4 minus 3 is 1. Absolute value is still 1, but this makes it negative. So negative 1 plus 1 is once again 0. And when we put in 5, 5 minus 3 is 2. Absolute value is still 2, but make it negative. So negative 2 plus 1 is negative 1. Okay, so I've plotted all my points, connected them with a line. So notice this time our vertex, notice how our graph is opening now, or where it's heading. It's heading down instead of up. So the V is kind of flipped upside down this time. So now our vertex here is a maximum value instead of a minimum value. So when we write our range, this time y is going to be less than or equal to positive 1 instead of greater than or equal. And just a few other things to note. Maybe you've noticed as we've gone through our examples, if we look at where our vertex is, notice our y values, because these are the same distance from our vertex, these will be the same. And these two values are the same distance from our vertex. And so these will end up being the same. So we kind of have some symmetry here with these graphs as well. So if for some reason you don't have that correct symmetry, maybe you've done some calculations wrong or something. If there's anything else that you see, feel free to point it out in class. But that's all we have for today. So I hope you enjoyed the video. Thank you for joining me, and have a great day.